Hi everyone, in this video we will be discussing mathematical induction. So, a mathematical induction is a method or a way to prove a theorem true where an infinite number of cases exists without exploring each case individually. So, ibig sabihin, ito ay isang paraan para mapatunayan or magpakita ng isang theorem na ito ay true na hindi pinapakita lahat ng cases nito. So, para mas maintindihan nyo yan, let us have our first example. So, prove or disprove the series by mathematical induction. 1 plus 3 plus 5 plus infinity up to the nth term, which is 2n minus 1. And the series is n squared. So, ibig sabihin, pag inad daw to up to the nth term, syempre, n squared daw. Okay? So, kailangan i-prove natin to with the use of mathematical induction. So, ang una niyong gagawin is to prove it using yung s sub 1, s sub 2, and then s sub 3. So, pag sinabi natin S sub 1, syempre, ang gagamitin natin to prove that it is true with S sub 1, ang gagamitin natin na n is 1. So, pag sinabi natin S sub 1, sum daw nung unang term. So, since S sub 1 lang naman, so ibig sabihin, ito lang yun. So, 1. So, 1 is equal to, so, equal daw yan sa n squared. Okay? Tapos, yung n, papalitan nyo ng 1. So, 1 daw is equal to 1 raised to 2. Pag pinalitan natin ng 1. So, 1 squared is 1. So, para sa S sub 1, true siya. Okay? Next one, i-prove naman natin with the use of S sub 2. Siyempre, kung S sub 2, n should be equal to 2. So, pag sinabi naman natin S sub 2, yun yung sum ng first two terms, which is 1 and 3. So, 1 plus 3. Equal daw yan dapat sa n squared, tapos papalitan natin yung n ng 2. Kasi nga, S sub 2 tayo. So, 1 plus 3 is 4. Okay? And then, 2, palitan natin to, yung n ng 2. So, 2 squared is 4. So, again, true siya for the value of n is equal to 2. The next one is to get the S sub 3. So, pag S sub 3, n natin is equal to 3. So, isa-substitute natin sa n ay 3. So, pag sinabing S sub 3, sum yan ng first 3 terms. So, that would be 1 plus 3 plus 5. So, equal sa n squared pa rin. So, 1 plus 3 plus 5 is 9. Okay? So, n squared, since ang n natin, we are dealing with S sub 3, so ang n papalitan natin ng 3. So, that would be 3 squared. So, 9 is equal to 3 squared is 9. So, true na naman siya dito. Ang sinasabi kanina, guys, dun sa definition ng mathematical induction is proving the theorem without using all the infinite cases. Kasi ito, 3 cases lang to. S sub 1, and yung n ay 1, n ay 2, and then n ay 3. Since infinite to, ayan, or hanggang 2n minus 1 siya. So, to prove this whole series na n squared sila, kapag inad sila, ang gagawin nyo, syempre, hindi nyo naman pwede siyang i-prove because there are an infinite number of cases. That's why we will use mathematical induction. So, yun yung ibig sabihin niya, nung sinabi niya na to prove a theorem true when an infinite number of cases exists without exploring each case individually. Because, sa totoo lang, hindi natin kayang i-explore lahat ng cases na nandito kasi nga, infinite siya. Okay? So, what will you do is with the use of mathematical induction. So, ang first step of mathematical induction is to, ito na yung first step niya, is to prove at least 3 cases. So, S1, S2, and S3. So, papalitan nyo lang yung N ng 1, 2, 3. Okay? Pagkatapos niyan is to show, to replace N with K. So, ang gagawin nyo is, i-replace nyo yung value ng K, ng value ng N ng K. So, basically, guys, papalitan nyo lang yung N ng K. So, 1 plus 3 plus 5 plus infinity up to the nth term. So, yung 2n minus 1 would be 2k minus 1. Okay? Is equal to k squared. Okay? So, this one, i-assume nyo siya na true siya. Okay? So, this substitution here of n with k, you will assume that it is true. Next one is, assume lang, guys, ha? Yan, wala pa tayo dun sa ating final answer. So, assume true lang itong series na to. Okay? Pagkatapos, yung n natin, lalagyan natin ng k plus 1. Kasi alam natin na ang susunod na term would be k plus 1. Diba? So, ibig sabihin, 1 plus 3 plus 5 plus up to the nth term, which is 2k plus 1, 2k minus 1, ang susunod dyan is magkakaroon ng plus 1 tong k. So, ibig sabihin, magkakaroon siya ng 2 times, so itong k na to would be k plus 1 minus 1, ayan. Okay? So, parang ano yan, guys? Halimbawa, kaya natin sinabi na k plus 1 kasi ito, halimbawa, ang n nito ay 1. Okay? Ito, we can say that this n here is n is equal to 1 plus 1. Kasi 2 to, n sub 2. Ito naman, yung susunod, pwede nating sabihin, n is equal to 2 pala. Ayan. So, ito, alam natin na n is equal to 3. But we can say that this is n is equal to 2 plus 1. Kasi yung sinundan niya, plus 1, siya yung kasunod, which is 3. So, ibig sabihin, ang kasunod ng 2k minus 1 ay mag-a-add ka ng plus 1. Kasi palaging nagpa-plus ng 1 sa n. So, ibig sabihin, ang kasunod niyan would be 2, tapos yung k plus 1 minus 1. So, parang ganun. Okay? Palaging ang kasunod ay may plus 1. So, ang ibig sabihin, ang kasunod nito would be 2 multiplied by k plus 1 minus 1. So, ibig sabihin, ang magiging series na natin ay hindi na k. Dito, naging k siya kasi ang nth term na binigay ay k. So, dito, ang nth term na natin is yung may k plus 1. So, ibig sabihin, itong k squared na to, yung k mapapalitan ngayon ng k plus 1 squared. Ito siya. Okay? So, pagkatapos niyan, guys, re-replace nyo naman ito, since this value daw, parehas yan ito, ito daw ay equal sa k squared. So, ibig sabihin, ito ay pwede kong palitan ng k squared. Itong buong to, since equal daw dito, equal daw ito sa k squared, kasi dito, inassume na natin na true siya, therefore, pwede kong palitan tong buong to ng k squared. Okay? Plus, so copy lang muna natin to, 2 times k plus 1 minus 1 is equal to k plus 1 squared. Okay? Tapos, i-evaluate nyo lang yan. Algebra lang to, guys. So, k squared plus, so ito, syempre, tanggalin natin itong parenthesis by distributing the value of 2. So, 2 times k, ito, 2 times k would be 2k. Ayan. 2 times 1 would be 2. And then, minus 1. Ayan, copy lang siya. Wala naman siya sa parenthesis. Okay? So, nawala na yung parenthesis na to. Okay? Equals, ito, FOIL nyo lang. Ibig sabihin yan, k plus 1 times k plus 1. Okay? So, since positive naman to, we can simply remove the parenthesis. So, k squared plus 2k plus, so ito, add nyo na siya. 2 minus 1 is 1. Okay? Equals, so ito, FOIL nyo naman siya. So, k times k squared. K times 1 is k. 1 times k is k. And then 1 times 1 is 1. Okay? Tapos, ito, okay na tong left side. Simplify na siya. So, ito, simplify lang natin. So, k squared, syempre, pagsasamahin nyo itong dalawang k, similar terms yan. So, k plus k is 2k. And then plus 1. So, pag nag-equal yan, ibig sabihin, ayan, mapoprove nyo na yung series with the use of k plus 1. Ibig sabihin, kahit na mag-extend pa to ng k plus 1 dito sa susunod na term after the nth term, same pa rin ng kakalabasan. So, ibig sabihin, na-prove natin itong series na ito. Okay? Kasi nag-equal sila. So, dapat equal to, guys. Okay, let us have the next example. Ayan. So, prove or disprove the series by mathematical induction. So, ang series na binigay, 1 plus 2 plus 3 plus hanggang nth term, which is n, is equal to n multiplied by the quantity of n plus 1 all over 2. Okay? So, again, gamitin muna natin si S of 1. So, ang magiging n natin ay 1. So, ang S of 1 is 1. Ayan. Is equal to, so, n times n plus 1 over 2. So, 1 is equal to, so, papalitan natin yung n ng 1. So, 1 times 1 plus 1 over 2. So, 1 is equal to 1 plus, so 1 plus 1, syempre unahin nyo yung parenthesis, PEMDAS tayo. So, 1 plus 1 is 2 all over 2. So, cancel to. So, 1 is equal to, and ang tira ay 1. So, tama siya dyan. Next one is for S of 2. So, S of 2, ang gagamitin nyo naman na n ay 2. Okay? Pag sinabing S of 2, sum daw nitong dalawang to. So, sum of the first two terms, so 1 plus 2 is equal to, so ang n naman, papalitan naman natin ng 2. So, 2 times 2 plus 1 all over 2. Ayan, pinalitan ko yung n ng 2. Okay? Tapos, add nyo to, so 3. And then, 2 times 2 plus 1 is 3 all over 2. So, ito yung canceled. So, 3, ang natira ay 3. So, equal na naman siya. Okay, the next one, so S of 3 with the use of n is equal to 3. So, pag sinabi natin S of 3, sum of the first 3 terms. So, 1 plus 2 plus 3. Tapos yung n dito, papalitan naman natin ng 3. So, that would be 3 times 3 plus 1 over 2. So, 1 plus 2 plus 3 is 6. And then 3 times 3 plus 1 is 4 over 2. So, 6, 3 times 4, that is 12. 12 over 2 is 6. So, equal siya dyan. Okay? Next one is to prove it by mathematical induction with the use of k plus 1 or n plus 1. Okay? So, unang gagawin nyo is to assume that yung k ay true. So, ibig sabihin, papalitan muna natin yung n ng k. So, 1 plus 2 plus 3 plus k is equal to k times k plus 1 all over 2. So, assume that this is true. Okay? Tapos, syempre, ang susunod na magiging value after yung k ay yung may plus 1 na k. So, magiging 1 plus 2 plus 3 plus, ayan, plus. So, k na muna, plus. So, ang kasunod na value niyan would be, i-replace nyo yung k ng k plus 1. So, magiging k plus 1. Ayan. Ito yan, guys. Actually, k yan. Pero, syempre, ang kasunod na value after k is k plus 1. So, papalitan nyo yan ng k plus 1. So, kung hanggang nandito na yung nth term, syempre, ang magiging sum niyan is mapapalitan to ng k plus 1. Okay? So, magiging, itong k na to would be replaced by k plus 1. Okay? Tapos, ito pang k na to na nasa loob. So, magiging ganito itsura niya. Ayan. So, k plus 1. Ayan. Tapos, yung plus 1 na yun. Ito. Ayan. Okay? Parang ito lang yan, guys. Ito yung k times k plus 1. So, basically, papalitan nyo lang yung k ng k plus 1. Okay? Kasi hanggang k plus 1 na yung ating sequence. Okay? All over 2. Now, ito ay parehas nito at ito daw ay equal dito. So, therefore, I can rewrite this as k times k plus 1 all over 2. Okay? Plus k plus 1 is equal to k plus 1. Ito guys, pwede na nating tanggalin yung parentheses kasi positive naman siya. So, magiging k plus 1 plus 1 which is equivalent to k plus 2. Tama ba? Ayan, k plus 2 yan kasi 1 plus 1 is 2. So, all over 2. Ngayon, i-distribute muna natin to. So, magiging k times k squared, and then k times 1 is k all over 2 plus k plus 1 is equal to, so ito foil muna natin, k times k is k squared. Ayan. And then k times 2. So, k times k squared, k times 2 is 2k. And then 1 times k is k. And then 1 times 2 is 2. All over sila lahat ng 2. Hindi nyo pwede i-cancel yan, ha? Katulad ng ginawa natin dito. Dito nakapag-cancel tayo, guys. Ito. Kasi multiplication lang naman yan. But in this case, addition to, yan. Hindi nyo pwede i-cancel yan, ha? So, nagka-cancel lang tayo kapag multiplication yung operation nung nasa taas. Okay? So, simplify lang natin to. Kailangan mag-equal yan. So, k plus 1, ayan, is equal to, so ito pagsasamahin natin, this should be equal to 3k, di ba? Kasi 2k plus 1k, so 3k plus 2, all over 2. So, basically, guys, ang gagawin nyo lang is multiply nyo na lang to by 2. Ayan. Para makancel yung denominator na 2 rito. Okay? So, pag dito siya minultiply sa first term, dalawa kasi yung terms eh. Ito, tsaka ito. Kasi may plus sa gitna nila. So, mumultiply nyo muna siya dito. Pag dito nyo siya minultiply, makakancel tong 2. So, ang matitira, ilagay ko na lang siya dito ha. So, ang matitira dyan, pag dito siya minultiply sa first term natin, so makakancel to, ang matitira lang ay k squared plus k. Okay? Tapos dito naman, pag dito siya minultiply, walang makakancel kasi walang over 2 to. So, ibig sabihin, mamultiply si 2 dito, so magiging plus 2 times k plus 1. Ayan. Tapos, equals, ayan. So, dito, makakancel din siya kasi pag minultiply siya dito, magiging parang ganito kasi yan, guys. Magiging parang 2, ito, pag minultiply siya dito, magiging 2 times k squared plus k over 2. Ayan, magiging ganyan siya eh. Plus, dito naman, magiging 2 times k plus 1. Dito naman, sa equal na to, magiging, pag tinime siya dito, magiging 2 times k squared plus 3k plus 2 over 2. Kasi naka-over 2 yan eh. Ayan. So, dito, sa unang to, makakancel yan. Ma'am, ba't sabi mo kanina bawal mag-cancel? Times naman to, guys. So, multiplication naman to. Ayan. So, pwede nyo i-cancel to nasa labas. Ang hindi pwede, nasa loob. Kasi plus to. Okay? So, ito pwede i-cancel. So, ang matitira, ito lang. Dito, wala makakancel. Kaya as is siya. Mamumultiply siya sa 2. Kaya ito siya. So, dito naman, makakancel siya. So, ang matitira dyan, k squared plus 3k plus 2. Okay? Tapos, ito, nakasimplify na to. So, dito na lang tayo magsisimplify. So, k squared plus k. So, distribute lang to. So, 2 times k is 2k. And then, 2 times 1 is 2. Equals k squared plus 3k plus 2. So, iayos nyo lang to. Siyempre, ang similar terms dyan is itong dalawang k. Okay? So, k squared, 1k plus 2k is 3k. Plus 2 is equal to k squared plus 3k plus 2. So again, ayan, na-prove na natin itong series. So equal sila. Okay? So let us have the last example of mathematical induction. So let's have 3 plus 7 plus 11 plus the infinity up to 4n minus 1, which is the n term. That is equal now to the series of n multiplied by the quantity of 2n plus 1. So again, s sub 1. So n is equal to 1. So ang s sub 1 natin dito ay ito, 3. So 3 should be equal now to this one with replacing the value of n with 1. So magiging 1 times 2 times 1 plus 1. Yan yun. Okay? So papalitan ko yung n ng 1 for s sub 1. So 3 equals 1. So unahin nyo muna to. So 2 times 1 is 2 plus 1. So 3 is equal to 1 times 2 plus 1 is 3. 1 times 3 is 3. So equal siya. Okay? Next one is for the s sub 2. So s sub 2, ang gagamitin natin ay n is equal to 2. So pag sinabing s sub 2, dalawa na sila. So 3 plus 7. Okay, equals. So papalitan ko naman yung value ng n ng 2. So magiging 2 times 2 plus 1. Ayan. So 2 times 2. Okay? So equals. So 3 plus 7 is 10. So equals 2 times, unahin nyo to, 4. 2 times 2 is 4 plus 1, 5. So 5 to. Ito. Yung nasa loob. So 2 times 2, 4 plus 1, 5. And then 2 times 5 is 10. So tama siya. Okay? And then s sub 3. So n is equal to 3. Pag sinabing s sub 3, sum nitong tatlo. So 3 plus 7 plus 11 should be equal daw to this one na nireplace yung n ng 3. So 3 times 2 times 3 plus 1. Ayan. Pinalitan lang natin yung n ng 3. Okay? So 3 plus 7 is 10. 10 plus 11 is 21. Equals. So ito, 3. Unahin yung nasa loob. Ito, yung mas malaking parenthesis. So 2 times 3 is 6. And then 6 plus 1 is 7. So 3 times 7. So 21. 3 times 7 is 21. Ayan. Okay? And then the next step is to replace with n with k. So magiging 3 plus 7 plus 11 plus k up to the n term. So 4k minus 1 equals k times 2k plus 1. Ayan. So papalitan nyo lang yung mga values na. And then you will assume that this series is true. Okay? So magiging kasunod nito ni 4k plus 1. So, copy muna si 4k plus minus 1. So, syempre, pag nag-plus ako ng another term, magiging magiging k plus 1. So, yung k na to, mapapalitan siya ng k plus 1. So, magiging 4, copy lang, times k plus 1. So, papalitan ko to ng k plus 1 minus 1. Ayan. Okay? Equal, since hanggang dito na raw tayo sa term na to, na k plus 1, so, yung mga k dito, mapapalitan din ng k plus 1. So, ito muna, palitan natin, magiging k plus 1. And then, ito, so 2 copy. And then, itong k na to sa loob, mapapalitan din siya ng k plus 1. And then, copy yung plus 1 sa dulo. Ayan. Okay? So, ito ay parehas dito. At ito daw ay equal sa k multiplied by 2k plus 1. Therefore, I can rewrite this as k times 2k plus 1. Plus, so ito ay distribute lang para matanggal yung parenthesis sa loob. So magiging 4 times k, 4k. And then 4 times 1 is 4. And then copy lang si minus 1 na nasa dulo. Okay, equals. So ito, k plus 1. So unahin muna natin tanggalin yung parenthesis sa loob. So 2 times k is 2k. 2 times 1 is 2. And then copy tong 1. Ayan. Okay? So, ito naman, para matanggal yung parenthesis, so distribute naman to si k. So, k times 2k is 2k squared. And then k times 1 is k. And then, ito, since positive naman to, pwede natin i-remove na lang to parenthesis. So, magiging plus 4k plus 3. Diba? Kasi 4 minus 1 is 3. Okay? So, 4k copy lang. Since similar tong dalawa, pagsamahin nyo na. 4 minus 1. Okay? Equals. So, dito, pagsamahin nyo muna to. So, k plus 1 times, ito, pagsamahin nyo na, since similar siya, 2k plus 3. Ayan, 2 plus 1 is 3. And then, combine similar terms. So, ito, magiging k plus 4k, that is 5k. So, 2k squared plus 5k plus 3. Okay? Equals, so ito, i-foil na natin. K times 2k is 2k squared. K times 3 is 3k. Tapos, ito naman, 1 times 2k is 2k. And then, 1 times 3 is 3. So, combine similar terms here. Ito okay na siya. Simplified na siya. So, ito naman, 2k squared. 3K plus 2K, syempre 5K plus 3. So as you can see, equal siya. Therefore, na-prove natin itong series na ito. Okay, so that is it for mathematical induction.